So you get a look and feel for this position and count approach. Assignment. Assigning new data to the string is quite substantial in terms of what's available. So it gets boring very quickly. So I'll just give you an example, a flavor of what's available. So we create string S1, which is empty, string S2, which is another empty string with no characters. Then we assign Fred to the string 1. So there is an overloaded assignment operator. By the way, operator overloading is going to be our next topic after this part of our discussion. And it's interesting that not just that you can assign C strings, but you can actually assign an individual character to the string. So this gets compiled, and what happens is that string 2 simply contains a single character as a result of it. So it's okay, it's possible to assign one single character to a string, right? So we get the flavors of assignment. So we can verify our assumptions by running asserts. Obviously strings can be assigned to one another. But there is a family of assign member functions inside the string which let you to assign kind of fragments. Like, for example, take this hello and assign 4 characters of it. So string 1 becomes hell, right? Then we can say string 1 assign 6 characters of A. And then string 1 becomes a string that contains six characters of A. So there are flavors and different possibilities of assigning brand new value to your string, right? For example, another version of assign is this. Say, let's assign to string 2 something new, and that new is take a look at string 1 starting at position 2 and take 5 characters from there. Starting from this position, go as far as this. Anytime we have a string, let me kind of keep it more or less clean. If we have a string, I don't know, name S1 or something like that, and we have the string of characters and everything. If I say, and by the way, I can demonstrate it right here. We have a working program, and if I remember how first time I tried to demonstrate position and count situation, we're saying, okay, let's go at this position and grab this many characters. Now, if I specified 200 characters, not 2 but 200 characters, this assumed to be okay. Because if this count, if we run out of characters, the end of string will be assumed. Okay? So let's try this. Let's try to compile it. And despite the fact that I'm asking for 200 characters, I should still get, whatever's available from this call into the substring. So I'm assuming that position was 1. So LO was printed as a result of this call. Now you don't have to come up with those strange numbers to specify, oh, this will probably guarantee that it's going to take me all the way down to the end of my string. Instead, you can use the all familiar endpose. So if in place of the count you're specifying the non-existing position, it's assumed that you want to go all the way down to the end of the string. Just that kind of thing. So this will work and will produce the same results. And so these are examples of string assignments, right? So the whole family of those is available. And again, if I look at the string class, its documentation here, nice place. So member functions, you have family of constructors. It talks about the destructor, which is present. There is assignment operator. There's some ways to iterate here. Here's a family of function that gives you information about the capacity. The size of the string and length of the string is the same, do the same thing. There is something that can tell you what is the maximum size of the string, which will be probably close to the, the biggest number that you can fit in the integer. We can actually print it as over here. We can go and say S1 print max size, right? Just do a cout of max size at the end of our little program here. New line, and find out what is the maximum size that you can possibly get. So the documentation says that the max size return maximum size of the string. So let's find out if this is what we expect. Again, let me close this window. All right, so that's how big it can be. All right, so this is how many characters you can fit in there. So this is not a surprise. This is like 4 GB, right? Close to 4 GB. So because this is 1,000, this is a million, this is a billion, and we have 4 billion. That's how big the string can be, 4 GB in size. All right, so that's fine. Okay, moving on, I guess, to overview this. There's also capacity. Recall that in the dynamically managed stack, we allocated twice as much memory, then again twice as much memory. So the capacity was there. So the string has the capacity every time you use it. And again, if you're concerned with memory management, I will tell you where capacity begins to play an important role. You may open a file and find out that its size is like 100 bytes. Or you may open the file and find out the size of the file is 2 GB. There is a difference. So your if you want to read this file into a string, then you may actually pursue certain strategy and say, I want to increase the capacity at certain increments, and there could be ways to manage the capacity before you even add new characters to your string. So that's why capacity begins to play a role in the strategy how you manage memory. So if you want to do it faster, you can do your own research on where capacity will play an important role in what you write. And reserve, by the way, is the method, the function inside the string which manipulates the capacity. Basically, it says request. I want this big the potential in my string, and so forth. Clear, you can check if the string is empty. Element access, element of course is individual character. And operator square brackets, we saw that already. You can also refer to back and front. Modifiers, append, push something, assign, we just saw that. Insert, erase, replace, and swap. All of these will work on ranges or for the entire string. So you can say, go at position such and such and insert something into the string. And so you can dynamically modify your string. So you can see there's a rich collection of all kinds of potential modifiers for your text. And the string-specific operations We used, for example, example of a find another string. The whole family of finds is available. For example, you can search the string from the end of it, not starting from the beginning, but kind of search backwards, and other versions of find. So there's this whole useful collection of functions built into the string, and you can see that this goes far beyond what C string offers you, right? It just allocates those characters, they're read-only, and you get the pointer to the first character. That's about it. So you can use it, but it's not it's not that rich as the string class, which is part of the standard library. Okay, so so these are potential examples of assignment. Similar to assignment, appending, same as assignment, but growing our string in size. Is basically the notion is that we can grow our string. Let me save this.